All right, hello and welcome to today's webinar. Thank you for joining us today. I am Chelsea McDougall. I'm the Editorial and Content Director for Labels and Labeling Magazine. Today, I'm joined with Maxcess Group, which includes RotoMetrics, Tidland, Fife, and Magpowr, for today's webinar that is aimed at improving tag and label converting from unwind to rewind. Today's session dives into the difficulties facing many label converting companies and how to overcome them. From thinner liners to challenging adhesives, new materials, and challenging applications, Maxcess will explore how winding influences tension, the effects of tension on guiding, and how guiding and tension impact die cutting and slitting. Today's session should last about 1 hour and is presented by Maxcess Key Account Manager Paul Young, an industry veteran with 32 years of experience specializing in converting applications within the narrow web industry. We are going to end today's session with a Q&A with Paul, so be sure to stay tuned until the end. But before we begin, just a small bit of housekeeping. On the right side of your screen, you should see a chat box. Please feel free to use this to ask any questions or add any thoughts that you might have throughout the webinar. But for us to easily track the questions for the Q&A, can you please put the letter Q before your message? There is also a feedback form located in the chat for you to give us your thoughts on this webinar and future topics of interest. If you do experience any technical issues, just try refreshing your browser and rejoining the webinar. The session is going to be recorded, so don't worry if you miss anything. We will be recording and sharing with you afterwards in an email, and it's going to be made available at labelsandlabeling.com. So thank you very much to Maxcess for sponsoring today's webinar. And Paul, I will turn it over to you.
Thank you, Chelsea. Hi, good morning, good afternoon, good evening to everybody. Today we're going to talk a little bit about improving tag and label converting, unwind to rewind. We're talking a little bit about dies, a little bit about processes, a little bit about applications. So whether you're purchasing, management, operations, I hope that each and every one of you get something out of this. And towards the end, I certainly welcome any questions. If you want to reach out personally, privately afterwards, tomorrow, that's fine. Love to have the engagement. Okay, a little bit about Maxcess. So I like to say that Maxcess is maximum success. So a little bit about Maxcess and where we behave in the tag and label market. So many of you might be familiar, but from the unwind from Fife web guiding to the middle of the machine, whether it's a Componex idle roll, maybe Webex rolls, heat transfer rolls, chill rolls, rubber rollers such as Valley Roller, tension control devices, Magpowr, international cutting die. Those are large custom non-woven web fabrication type dies and die modules. RotoMetrics, as you see, fits in the middle there, and that's all the rotary tooling. Vision inspection, and then lastly, slitting and winding. So we're back to the other end, and that's where we talk about air core holders, air knife slitting, razor slitting, automated slitting. So well-rounded in your operations, whether our team needs to talk about tension and how tension affects die cutting, whether you need to talk about core holders and how you wind those rolls, whether you need to talk about the cutting aspect of it, we certainly have it well-rounded. Okay, a little bit of the agenda here. We'll try to stay to this, but I may deviate a little bit. Converting expectation versus reality, and that's what we want to really kind of make a good example of, because that's the beginning. That's where we want to start the jobs. Different materials, whether it be challenging, application specifics. We'll talk about a few challenging ones there. Tight, intricate designs that may be blade spacing the tooling, die life. And of course, what we all are seeing in this industry is retiring workforce. Okay, so before we begin, this is kind of a mantra I kind of like to have, and I think we all need to have it in our plants, whatever end of this plant we're on, is that's becoming better, faster, and smarter. Okay. Challenge, expectations versus reality. So for everyone here, purchasing, management, operations, maybe you're a salesperson in this industry, What do we want from the expectation? What is reality? How do we get there? Right. So you see the little climber there on the right hand side, and you see Maxcess up there. So we're there to help pull you through those. So one of those might be trying to sell into new markets. Maybe it's a market you're not traditionally experienced with in manufacturing. Um, Maybe it's finding a new way to boost the current operations, improvements. How do we improve the current processes? Maybe there's some lines, maybe there's some label production jobs that you just don't feel you get the efficiency out of. Maybe it's waste control, maybe it's machine uptime. Maybe it's a waste, decrease in waste initiative that you have. That's attributed more to setup time, improper tooling used, how to implement sustainability initiatives. So that's certainly under everyone's spotlight these days. And maybe you want to go down to some thinner liners. Maybe you want to go to some thinner face stocks. If your supplier's changing materials, how do you know you have the tooling set up to do that? Because the first thing you want to do is come in with that new material and produce a dollar, right? I kind of say labels are dollars, but in any case, maybe you need to improve repeatability or traceability. Maybe you're in the pharma space. Maybe you're in sequential numbering. So that's what we want to look at too, is a lot of repeatability and traceability. And that's where we talk about project building, project discussions, expectations versus reality. Okay, I say get a plan. So in any time we look at those new markets, new initiatives that we first have to have a plan. So an action plan is collaboration. So one of the suggestions that I always like to say is, let us know what that challenge is. Let us know that application. We've got 24/7 support. Let's talk about what your business needs are, and then let's build a plan together. Collaboration, solution, defining the expectations. So over the many years, we see a new company want to get into a different market, and they say to themselves, I have a mag cylinder, I have a machine, and I have flexible dies. But there's a much deeper aspect to that. You need to break down the substrate. Is it a thin and thinning liner? Is there liner variations to deal with? What's the delivery time? Are there adhesive challenges on that? What often is the adhesives? Acrylic, rubber base, is a hot melt? Is it this or that? And then the converting expectation. How fast we're going to run this on the machine? What kind of downtime? What time of changeover time do we want to be in there? So we're defining the expectations, building in the unknown to find out what that is and to be cost effective on the job. So define the expectation, what material is being converted, what is the machine, what is the asset involvement, experience and environment. All too much we talk about this, and we come in and we do their handling training seminars. But if you have something specific, maybe it's one line, one press, and you say, Paul, listen, we need to talk about operator training. We're going to go into this new product. We're going to go to this material. This is what we have. How do we get there to the winning line? Environment. How do we clean our environment? How do we keep the machines clean, the tooling clean? All this will be a great impact on how you make money on that job. So at the end of the day, what are your expectations as the customer, your customer on the end? Okay, challenging applications. I think the industry knows we've mostly converted to flexible dies nowadays. There are some applications, whether it's possibly metal to metal, maybe it's a application that the material is really thick. Maybe you still have some of the cases where some older operators, or let's say long tenured operators, still believe that the solid die is the preferred method. So in these cases here, let's have the discussion. Let's have the collaboration and talk about the pros and cons of each tool, because we do offer both of those. So setting the best foot forward is having the engagement to decide solid or flexible dies. Challenge. Here's the challenging material. So I wanted to pick this one here and it can be applied to a lot of different applications. So in this case, it is dairy labels. So many are familiar with dairy labels. Some people have engaged fully in it. Some people do a little bit of it. It seems to move around a little bit. So we're talking a thin laminate. We're talking a paper face most often. And what we went down to is a 92 liner. So some of that common criteria we know about this type of application, we have to have low waste and we have to have low scrap. Die strike is critical. We're going to go on application machines that we don't know where they're all at. We don't know how well they're maintained. So it's going to be die strike critical, especially on 92 gauge liner. There's no accidental deep die strike that's going to work. It has to be perfect or nothing. Higher press speeds. We know we want to run these 300, 400, 500 feet a minute. Does someone want to say 6? So we're looking at higher press speeds. Volume. Typically, we see this a lot of high volume. Margins can be a little bit slimmer. And then, of course, tooling costs. So at the end of the day, what you invest in your tooling, that be the flexible die, be it the mag cylinder, etc., we have to make sure that we build this in to be the lowest cost per 1,000 labels produced. So it won't be about the least expensive die. It's about the highest quality value die. Again, I circle on the top. It's the plan. So we have this discussion, the collaboration to understand what you need and what your end user needs. So execute the plan. How do we execute the plan? So whether you're already in this business or this is something that you're looking at, maybe one of your salespeople's out there and bring something to you and say, hey, we think if we want to get into this dairy label business. So that plan we talked about, we're going to execute the plan, have a discussion. So we want to move forward with saying, okay, what is the best recipe for success? So whether it be the flexible die, we're going to be looking at Durafilm dies. So you're going to look at something that's going to have the longevity. You want the sharpness, and you want the best value for the best die strike. So it's a tight tolerance die. RotoRepel non-stick, that's the coating we put on the flexible dies and or solid dies. That's going to improve your uptime. So oftentimes double hits of adhesive, you're going to build up that adhesive quickly on the floor of that die. And as most of you know, that flexible die typically doesn't have the engraving depth that a solid engraved die has. So the last thing you want to have done is the operator having to shut down that machine because labels are going up the matrix because the adhesive flow has filled up from the base of the die upward and is impacting the face stock of the label. So that's going to be the improvement. That's going to be a significant labor time, machine uptime savings by using the RotoRepel non-stick. Magnetic cylinders. Another part, this is part of the plan. We validate the mag cylinder, understand the undercut, but most importantly is understand the build of that, whether or not it's a stainless steel, whether or not it's fully hardened bears, whether it's case hardened bears. We oftentimes see consumers or buyers buy these mag cylinders by the price, but not really understand the long-term effects using it in the job from which it was intended to do. So we'll also have that discussion in the plan of what your end use is going to be. Anvil roll, precision ground tool steel anvil rolls. We'll talk about that. Maybe we'll do a site visit. We can help you look at the operations of the die station, how well they are. That'll be your success. So we're building, if you notice, we're kind of building a recipe for this. Hydrojack pressure measuring systems. You can never get a speeding ticket if you got a speedometer. That's my old claim to fame, what I say. Hydrojacks are a pressure system to know that pressure that's used on the die. So what we get then is we know the starting points, we know the ending points, and then you have repeatable consistency. So we don't have to stop there. So we also keep improving. And how do we keep improving? So within that die station, within that die cut area there, an operator may have other challenges. Let's say that they don't have great consistency on stripping, pulling the matrix up. So what would it mean to add an easy, clean stripping roller in there? because what you'll typically see, and take a look around your machines, you'll see a lot of matrix scrap stuck on idle rolls, stuck on the stripping rolls, and that starts to create a little bit of a web tension issue or deviation of the matrix as it's going up at a high speed. So we want to eliminate that. We know it's going to happen. We know scrap's going to happen. We know wrap-ups can happen. But the fastest way we can get that machine up and going, and the best success by not having that happen, is what we want to do. We can also insert adjustable anvil systems. We can go fully automated. We can go basic. So in this case here, again, 92 gauge liner, dialing in that critical die strike. Each component in there has a tolerance. So the tolerances accumulate. That adjustable anvil is going to help you dial in the die strike. It's going to assist in a little more die life versus if you were running and you maxed out your pressure, but the die is still stable, meaning sharp and consistent. We're going to be able to move that liner closer to the blade and continue running. So again, this is where we start with the plan. We execute the plan. It's all about the collaboration and discussion of what you want to achieve. Challenging materials. Here's another pretty big market here. Thermal transfer, direct thermal, various liners. So whether you may buy from one supplier this month and you buy another material from another supplier the next month, we know that there is material liner thickness variations. Now we may be talking tenths of thousands. We may have a little bit of a density, but typically for most buyers of dies, they see it as it's a 40-pound liner. That's all they know. That's fine. So whether you do this now or whether you want to look into this type of a market to bring into your business, a common one, let's just say it's a 4x6, it's a blank label. Not a lot of value in that. There's no print in that. Some of the common criteria or challenges: low waste and scrap. Obviously, we don't need to be taking 15 minutes to set up a die to get it to work. We don't want die strike errors and you produce that and have to rerun the job. Worst case scenario is when that job leaves your door and it goes out to the end customer and they start breaking on the applicator lines. Then we have a whole bunch more problems. So low waste, scrap, die strike critical. Treat everything as critical before it comes critical. That's what I like to say. Higher press speeds. This market here, when we start to hear 500, 600 feet per minute plus, that is starting to become the norm now. So as you keep up with the competition, we have to increase those press speeds. So it can be a high volume, again, a potential low margin. You don't know who you're selling it to. So again, all those will be important. Lowest cost per 1,000 tooling, it's the same as like the previous slide I talked about. So the last thing you want to do, you got a job, you got to do 1 million feet of material, but now you have to buy 3 dies to convert that 1 million feet. So we think about that and say, what is the very best die with the very best die strike that can create the lowest cost per 1,000 produced for you? All right. So this is, again, the recipe or the plan. 26-inch wide machines. We are seeing this market become much more wider, running one more across. So now you can imagine the press is going 500 feet per minute, 26 inches wide. I'll bet that you can produce a lot of scrap very, very quickly. And then that same thing being is that if this machine goes down, the cost every hour that machine is down is costing you a significant amount of money. So again, go back to the plan and execute the plan. Liner variations, that's a challenge. That's real. That's been happening since the last liner challenge, 4 years ago, I believe, something like that. So we're going to constantly have to evolve to the material tolerances that we get. That's a lot of challenges, folks. Solution to challenging materials here: the thermal transfer, direct thermal, various liner thicknesses. Let's execute the plan. Remember, so we collaborated, we talked about it, we understand your expectations, you bring to the table what your customers are looking for, and we therefore write the recipe. So this recipe might be flexible dies, It would be in a longevity Dura die called our Dura paper die. It has a specialized chromium plating, pretty unique to us. RotoRepel nonstick. Certainly this would lend itself to that because the same thing goes as the previous slides. We don't want machine downtime. If you add up whether it's 300 an hour, 500 an hour, 700 an hour, if I do the simple math and add that up over every month, that's a substantial amount of money in savings only by adding the RotoRepel. Again, magnetic cylinder. The last thing you want to do when you bid these long run jobs out, stock label jobs, is have to mid-ship in the year buy another $2,000 magnetic cylinder. Nobody planned for that. Nobody built that in. So if we go with the high quality stainless steel bodied JBAs, it'll carry you through the year. It carries you much longer down the road without repairs and replacements. Precision ground tool steel anvils, hydrojack pressure systems, vortex cooling systems. When we get into a lot of the really high speed, high pressure applications, we do get thermal expansion. When that happens, operators do react somehow. They may take pressure off. Sometimes they may have to put more pressure on, depends on which way the expansion affects the die strike. So again, we'll have this discussion with you. We'll talk about the project. And then we want to keep improving. Same thing here, easy clean stripping roller, AccuAdjust adjustable anvil. Maybe it's Maxlite stainless steel cylinders, lightweight stainless steel bodied, because these 26-inch wide machines, that's a lot of weight to be moving around. So we want to talk about safety in that nature there and how those can help you. Another challenge, challenging materials. Talk about filmic faces, stretchable, extensible face stocks. Some of those face stocks are getting a little bit thinner now. And we talk about thin liners. Let's say maybe a common one we all know about is global MDOs. Some people have found that challenging still today. There is some easy resolution to that. But again, we go back to the plan. I always talk about the plan. You're probably tired of me talking about the plan by now, but this is what you need to do. So what is a common criteria? Low waste scrap. That always comes up on all the slides, especially here. Now, this type of a product here, we've invested a lot of money in it, right? Whether it's rotary screen, double bumps of white ink, it's 4-color process. There's a lot of money and time that goes into that label before it even reaches a die. Before that die even touches that label, there's a lot of cost involved. This in itself too is die strike critical. We see a lot of these type materials on thin gauge liners. We see it on 1.2, 92 is starting to become more and more prevalent out there. And these type of lines, they're probably expensive application lines. So certainly they don't want the downstream challenges of shutting down their bottle filling lines because of deep die strike breakage. Higher press speeds, we all want to achieve that. As we look into 2026, I'm hearing from the industry, we're going to really take a good look at how we perform on the presses. And this is the criterias. We've accepted maybe it's 200 feet a minute for prime. What if we got to 3? If you could improve from 300 to 325, how much money would that help out? High volume, high value. Again, let's talk about lowest cost per 1,000 in your tooling cost. So white inks are abrasive, TiO2s, rotary screens even more difficult. And of course, the erosion rate is a little bit different. Therefore, if you're not careful and you buy the cheaper die, you're going to be buying more often. So you always want to look at what annual spend is attributed to your tooling. MDO, thin white inks, we talked about that. PET liners, 1.2 to 92. It would not surprise me that you may start seeing 75 gauge liners pushing more and more because of sustainability, recyclability, that will happen. So anything that you do now currently will have to be looked at a much closer detail on the plan and the execution of how to get you there. Razor blade slitting. This is another one that has came out more in the PET film the last several years. Is how do we convert that? How do we strip the matrix and slit the sides? RD scoring, is it automated? Is it razor blade? We'll talk about some of those options to do in some other further slides. Solutions. Here's some of the solutions. We talked about the plan. Now it's time to execute the plan. We're going to build the recipe. We're going to make it successful out of the box into the machine, and it performs. Flexible die typically for this is what we call the gold line special, coined the old electro-optic beverage die. But as more and more filmic materials come into the market, we understand that dies need to be sharp. They need to last. RotoRepel again is another one that's just a value add that's hard to not get on the dies when you understand the values. Mag cylinder, again, building this recipe, stainless steel, JBA XT. JBA means journal bearer assembly. So that's a robust, repairable, high quality cylinder. Precision ground tool steel anvils, hydro jacks, and again, vortex cooling system. So as the thinner liners are and the press speeds come up, you get the thermal expansion. So we want to manage that thermal expansion. So as we get into improving these, at the bottom there, you see an RD Auto Score, which was developed by our Tidland group. So currently right now, you may have a traditional RD score, but you may have challenges on scoring, slitting the liner to the face stock. So that product was designed to remove that problem and also put in automation, meaning the RD Auto Score has presets for your distance between the blades. It also has presets to set the depth of the cut to the face stock. And everything is automated. So on the HMI, you can save them per customer name, job number, and retrieve that and let those blades go into the auto position at any time. AccuAdjust anvil systems, that's another great added value you can put into that line. Again, it's about improving what may already be great today. How do we make it better? Duraline special dies, unique to us. One of the sharpest dies in the industry, but also uses some coatings called chromium. And how you chrome those dies obviously is a little bit specialized. It's not just putting chrome on it. It's a way you put the chrome on it. So essentially here, we built the plan, we execute the plan, we write the recipe, and then we add added value to these to improve the operations overall. Application specific challenges. This goes without being said. We have some assets out there that are older. Maybe they don't have the very best registration. Maybe they don't have the very best guiding, but it's an asset that you have on the floor and you need to make good with that asset. So if there's some line changes that we could do or have a discussion about, we would have the products such as web guiding. Maybe you have multi-streams and you want to guide two webs together. Maybe you have some registration. Maybe it's just print to print registration. It could be a print to die registration challenge. For example, if you have multiple die sets, they all equally can be pulling the web and changing the tension because it's before the exit tension system. We may look at transducer rolls or do something a little bit different in the tensioning system. Okay, other application challenges, adhesive issues. That's one that we see all too often. You may see it on the idler rolls on certain materials. That, of course, if you see it on your idler rolls, most assured, you're going to see it on the cutting die. Most assured, you're going to see it on the rewind. Maybe it's even finishing. So that continues. So we know adhesive is always going to be there. We know where they all start. How do we find the solution to minimize the impact of that? The last thing you want to have is labels going out to your customer that are sticking to the backside of the liners. That certainly is not a fun issue to deal with. Maybe you have specialty machines. RFID comes to mind. That's one nowadays that we're hearing a lot about. Maybe it's extended content labeling. Maybe you're in a market in pharma and you have multiple webs coming down. So specialty machines, let's call it. Thin webs, maybe you do some industrial labels on thin webs. Maybe it's only a 5/8 inch wide. Thin streams, let's call it. Maybe on a turret rewinder. Maybe some challenges there. How do I wind up? What's my winding look like? Am I able to wind these small, narrow rolls onto a core without them coining or without them being too tight in the center? Solutions, adhesive on idle rolls. Componex, we have multiple different coatings and also offer plasma spray for coated rolls. So this would help eliminate that picking of all that adhesive that we spoke about. Consistent edge trim from Tidland. There's lots of series of different knife holders that we can deploy in any operation, whether it's paper or films. Maybe it's crush cut, maybe it's shear knife. If you have that challenge, if you have maybe you have 7 lanes across and you lose a lot of time and consistency because your operators have to use a measuring tape. That can be a little bit inconsistent at times, and of course time consuming, and therefore the cost of the machine is down because they're trying to position knives manually. Inconsistent rolls, you've heard of tape retention before. Again, it could be hot foil, could be cold foil, it could be narrow width labels. That's where we talk about the Tidland, the differential air shafts, the way each of those individual streams wind up correctly at the same rate. Okay, here's a challenge one. This is becoming ever so popular. Intricate, tight spacing of blades. So we know tamper security, RFIDs. More and more, we're looking at how do we get blades closer together. Maybe it's decal edging in the wine label markets. So as brand owners, they come to the label company and they say, I want something really unique. I want something that really stands out on the shelf. Those applications you bring to us, and we will look at how that project is, write a plan, and how to execute that plan. Vision inspection, also offer vision inspection systems. Label lift, adhesive whip back, especially you hear these very tiny labels, Kapton, polyamide, polyamides. There's a secondary process that typically happens. So we cannot have any chance of label lift and adhesive whip back. Here's some of the solutions. RotoMetrics microblade dies. We offer, I still believe, the tightest spacing of any flexible die manufactured for blade spacing. Maxcess vision solutions. And then, of course, the RotoRepel coating, flexible dies or solid dies. So simply, if it's a new market or an existing jobs you already have, break each of those down. I heard the term waste walk a couple years ago. So take a walk out in operations and look at a job saying, you know, we're not making a lot of money on this job, but it needs to be improved. We can also help do that with you. We're going to break down each of those processes. We're going to look at supply chain that comes into those processes and help you make the good recommended choices on what's best. It's a sticky business some days. I probably talked about RotoRepel 4 times here, but it's a product that's just absolutely has lent itself leaps and bounds, especially on the flexible dies. If you have slow run speeds, again, the adhesive whip back, you get label lift. Oftentimes label lift, you have to be careful that it's not mistaken that you think the die is bad. When in event the case is, it's simply built up adhesive on the blades that's engaging to the face stock and going up in the matrix. So again, that solution is the RotoRepel, 4 times longer or more than existing industry standards. It does not impede the blade profile. So there's no break-in time. So you figure there's no material waste. You don't have to wait for that to work. It's immediate, out of the box, it performs. Here's an example here, RotoRepel at 40,000 revolutions. I believe this was a tire label, a label-like tire label stock. And then there's the picture on the right there that kind of shows that adhesive starting to build up. So since we have a much shallower engraving or milling depths on flexible dies, it doesn't take very much from the floor of that base of that die to build up and start impacting the face stock of the label. And of course, labels lift. The right die for the right paper or film application, 2 times the die life. This is always part of the recipe. It's always part of the discussion to value your money, whoever's buying this die, a die for the application, whether it's a short run die, starts down at the basic smart flexes, or you need something what we call a workhorse, general film, general paper die, prime series dies, ultra films, special films, Dura series. We start to go up and we ramp up in longevity, durability. That's where we talk about that lowest cost per 1,000 produced. So it's smart buying and making a smart decision of what you need for the expectation. We move into the Dura series. We talk about Dura papers and Dura films, TiO2s, long runs, and then we move to sharpness. As we increase the sharpness to the right, we talk about the gold line special dies. That's one of the sharpest dies. That's where we cannot have impact to the liner and create deep die strike. That's that die we talk about for thin films, thin film face stocks. You cannot allow that to stretch around, wrap around the tip of the blade, because once it does burst, because die cutting is bursting, you can't have it into the liner. Micro blades push out to a specialty die, close blade spacing, specialty tampers, very unique. But again, let's have that discussion if a new project comes about. Okay, aging workforce. Nobody likes to say aging workforce. We're going to say retiring workforce. A new generation's coming. The new generation tends to like to have verifiable input, verifiable output, HMI screens, repeatability, consistency. Some of these solutions on here are the RotoMetrics AccuAdjust, which has multiple levels of technology changes from the mechanical dials to an HMI, all the way to a full solution called RotoAdjust. So if you're looking for traceability and tracking, you want to know, okay, within this time, this die, we had a potential problem. How do you isolate that? How do you retrieve it? The last thing you want to do is get 2 or 3 skid loads of labels in and not have traceability of where that potential die strike error could be. So this is something where we have to, in 26, start to look at automation of these converting lines. Slitting, another one again here, I talked about earlier. Go out to your press lines, look at your slitting operations, and look how we might currently do it today with maybe a tape measure. So now we can say, let's put this in workflow automation and let's retrieve the information. It could be information that's downloaded from somewhere. Maybe you set up the first job, and if it's repeatable jobs, you enter the customer number, the customer name, the blades automatically go to position. You want 0.625, 7 lanes, press the buttons, let the knives do the work. That's consistency and repeatability. So challenging, there's the solution, insert automation. So before we close, back to the very beginning, We ask ourselves, we ask operations, we ask purchasing, we ask management, how do we all become better, faster, and smarter? That's all I have. Hopefully we have lots of really great questions. We're going to do the Q&A, and then if there's offline here is my email address. Here is my personal number. Everyone's welcome to call me and start talking about the solutions. Thank you.
Great. Excellent. Thank you, Paul. That was really, really informative. I appreciate that.
Well, thank
So,
you.
yeah, we do just remind everyone, if you have a question or a comment, just please put it in the comment section. I see we have one here. It says, what's the best way to track revolutions on a die, and how important is that?
So it's very important to do, and I think we used to do it a lot more than we do it now. And what we traditionally see is a page, an 8.5 by 11 sheet, typically in the die package. And we only hope for the operator to remember to write that down. That's a great way to do it. It's a great start to doing it, but you have to make sure it gets done. So some newer options, the RotoAdjust that works with the AccuAdjust anvil system is an automatic system that will track that by the serial number. When you run the job, your start and stops will record that information.
Okay, great. Yeah, and I loved your man with a plan, I will say, and that's just,
Gotta have a
something I
plan.
wish. I
Gotta
love.
have a plan.
What would you say? What's a plan for converters, maybe to kind of future-proof their equipment as much as possible as all these materials evolve, like you were talking about?
Again, it's collaboration. Whether a material supplier comes in, whether it's the tooling supplier, you look at supply chain that comes in, and you have process chain, and all those have to align together, because the last thing you want is this person says, well, that changed, that's not my fault. But when everyone's on the same page for the end result, the collaboration, you will have the best success.
Yeah. Yeah. So we have another one here. What variables do you look at if you are seeing adhesive buildup in a printing and die cutting application?
So what I look at, some of the variables before it even gets to the die station of the converting operation. One is to know what type of adhesive it is, what coat weights are. Is there anything from that supplier that could note, hey, this can be a little bit challenging? And then where the material stored is one really important one, because summertime comes, it gets hot outside. A lot of times materials are stored in warehouses and they come directly straight to the machine. So I don't think everyone can afford to have climate controlled storage for that. But at least bring in material, sometimes a roll or two ahead of time, potentially get it kind of closer to the ambient temperature of the machine you're going to be converting at. And that will certainly help. So material, typically where you see adhesive on the idler rolls pre-converting module, that will be your sign. If you feel a lot of adhesive on the outsides of the rolls, that's typically a sign that it potentially could have a few challenges with adhesive.
Yeah. So another question from a friend of ours in Canada, actually. Hi there, Sean. He asks, you talked about storing materials. What's the best way to store the dies?
Hey, Sean. So the best ways that I find, and where I think I find my suggestions to tell you this, Sean, is by what I see in the field. So die should always be cleaned. They should be lightly oiled. There is typically, with the RotoMetrics, there's a blue bag, and that blue bag is to help resist any of the rusting. So that is typically hanging in file folders that hang. If you choose to put them in, say, the Gelima envelopes or so forth, you still need to have that same process put into place in order to keep them from rusting. So a lot of great ways out there, but at the end of the day, for any storage, especially when it hasn't been used a lot, or you're in an area where the climate, the humidities can pose challenges, then protection is the best.
Yeah. Okay. And then this question here, what does TPH mean on my flexible die orders?
TPH. So there's always a lot of information on order confirmations, and I always say I love to teach customers what that information means. So TPH is the total plate height. So the plate height is measured from the back of the die to the tip of the blade, and that will be decided upon what liner you're cutting down to and what the undercut is on the mag cylinders. So as we get more and more deeper into a challenging application, we may want to have that discussion and say, what is the TPH of the dies you get currently today? So knowing your tooling, what do I buy? What did I pay my money for? Understanding paperwork, understanding the basic elements of that flexible die will improve everyone's end result.
Great. And then what about, companies that have various magnetic cylinders from different suppliers? Does that matter? Should they have concerns? Is it all one size fits all?
It's not quite a one size fit all. I believe that there's been some good standardization probably in the last or over the last 10 years. What we kind of like to do is a fingerprint. So no different than what a printer may want to fingerprint on the print side of the machine. I like to consider it or call it fingerprinting the die station. And one of those would be a magnetic cylinder audit to where we can verify what the undercut is. And the undercut is that difference between bare and body, that it's consistent or within a consistent range that fits the end result. So we would offer that. That's very important, how the dies cut, too light, too deep, and that's going to build that consistency across the board.
Yeah. Okay. And what about the time to ship? Is it the same amount of time to ship a flexible versus a solid die?
Flexible dies most often are faster. For example, we ship many dies same day. 70-80% of the dies ship the next day after order receipt. Solid dies depend on their elaboracy, how big they are. Those would take, sometimes we can do next day. It might be several days, depends on the complexity and the size.
Okay.
The flexible dies certainly aren't the big, large, big, huge cylinders, and we have shipping time. So yeah, flexible dies would be faster.
Got it. And then is it true that one die will cut down to all 40-pound liners?
No. So when we talked earlier and had some slides in there earlier, we talked about different suppliers. So oftentimes we are still calling something 40-pound liner, where from supplier to supplier, a 40-pound liner could be a 2.1 mil thick, it could be a 2.3 mil thick, and also density. So what we would suggest in those cases, if you move to a different supplier, rather than find out later that the clearance needs to change, is we welcome you to send material in. We'll have our tech support group do an evaluation, and we'll supply that information of choices, meaning here's a hand applied, here's a moderate, here's an auto. If we need to talk about super auto, then we can have that discussion again. But we'll find this out, and you'll want to find this out before you go to the machine and start turning that die and making waste to find out that it's no good. So collaboration, having the plan.
Okay, having a plan. Okay, so one more, and please, I feel like we're getting to the end of the questions rolling in, so now it's kind of your last shot here. In a situation where the liner is separating, so the face adhesive liner becomes the face adhesive liner, would you suspect a machine issue or a stock issue?
So let me read that there. So when I see face adhesive liner becomes face adhesive liner. So we're not talking piggyback. It almost sounds like, Jules, that are we talking about delamination where the die is cutting too deep past the siliconization and want to delaminate the liner? I'll wait for you to reply on that, Jules, if you can. And if you want to get a hold of me, Jules, yeah, that's what we suspected. Okay, yeah. Yeah, typically, and we see this even more when we get, let's say, 50-pound liners, or we have less density to a liner, if we do have that deep die strike in there, that's exactly what happens. And there's an easy solution. Let's look at the mag cylinder if that's what you're using mags. Let's look at the die height. Let's do a material evaluation. Look at what that face stock we're cutting through, because that's important too. Because if this is particularly in the thicker, softer liners, we may err for a little different blade tip sharpness on the die itself. We don't want to push, and we're waiting for that to burst, but we're cutting to a mattress, for example. If the liner is very fluffy, we're cutting to a mattress, and then the blade continues to engage to be too deep. Therefore, the delamination occurs. Jules, get a hold of me anytime. Email me or call me if you want to talk deeper into that problem.
That's what I was going to suggest. Maybe Paul, if you want to tell people once again for a final time how to reach you, in case there's other questions that come out.
Yep, two ways. I'm gonna say what my email is, and I'm gonna spell it out. It's PM Young, YOUNG, PM Young at Maxcess, MAXCESSINTL.com. And you're welcome to personally call me on my cell phone. And that number in the US here is 678-314-8626.
And I just, as you were talking, I just typed that into the chat too. So if anybody wants to take a screenshot or quickly grab that information. But thank you so much, Paul. Yeah, incredible wealth of knowledge here today on this webinar that hopefully people found, enlightening and useful for maximum success, as you said. That was
maximum success, absolutely.
So again, thank you once again. Oh, you have a comment here that, Paul, you're the best no matter what anyone says. So.
Thank you, Sean. I appreciate it. And thanks everybody for joining. We could talk all day. There's so much more to just the slides within 1 hour. But again, get a hold of us. Let us know how we can help out.
Great. And again, if anybody wants to rewatch, this is going to be available at labelsandlabeling.com. And then I see that we just added a feedback form if you have any comments about this one, or maybe have some ideas for future topics. So thank you so much, Paul. Thank you, Maxcess, for the support. And thank you, everybody, for tuning in.
Thank you, Chelsea.
Thanks. Bye.